If we look at high-speed designs starting 20 years ago, a lot of things have changed. Speeds were comparatively quite slow and layer counts relatively low, allowing for very wide design margins. PCI Express debuted in 2003 at 2.5 gigabits per second. In 2007, PCI Express 2 was released and provided speeds of 5 gigabits per second, doubling the overall speed in about 4 years. PCI Express 3 released in 2010 at 8 gigabits per second, 4 came in 2017 at 17, and 5 was released in 2019 at 32. And most recently, PCI Express 6 was released in 2021 and offers speeds of 64 gigabits per second. If we look at other interface standards along the same time frame, we see them all fall within this same trend line and show the same rapid growth. Gigabit Ethernet starting in 2002, SATA in 2005 and 2008, USB 3 and 4 from 2010 and 2022. At this stage in the game, we can't afford to continue designing with the same mindset and tools used even 5 years ago. Too much has changed, and you've got to pay attention to a lot more details. If we think of all the things that we must now pay attention to within PCB design, we can roughly break them into 3 main groups: mechanical parameters, electrical parameters, and signal integrity issues. Within these groups, a significant number of the factors within link directly to the stackup. Your stackup touches all the signals within your boards and essentially forms the backbone of your design. Gone are the days of specifying FR4 and being done with it. There are now dozens of laminates available in dozens of configurations. Punting this decision to your fabricators was fine 5 years ago, but if you are working on high-speed boards and using multiple fabricators, you are going to have to start getting serious about your stackup design. While there are dozens of specs that exist for any one laminate, there are essentially 6 big parameters that you should be considering when making a material selection. These values will appear in your manufacturer's slash sheets, and understanding them can go a long ways. These basically fall into the categories of electrical parameters like dielectric constant or dK, and dissipation factor or loss tangent dF. And thermal parameters such as glass transition temperature, Tg, and decomposition temperature, represented as Td. And then there are coefficients of thermal expansion, our XY coefficient of thermal expansion, and our Z, CTE. Other less significant mechanical parameters like Young's module, Poisson's ratio, peel strength, and water absorption may be important in unique instances, but are generally less important as a whole when looking at material selection. It is these mechanical parameters battling against the electrical parameters that form the crux of dielectric material selection. Having a complete stackup planning tool like Z-Plan or Enterprise helps to manage and plan your stackup. It contains a stackup calculator focused on electrical impedance and signal integrity that helps you manage and optimize your PCB stackup design. Its library of PCB laminate materials helps to reduce material costs without sacrificing performance.